Alright, welcome to lesson 12-3. In this lesson you're going to learn how to make a box and whisker plot and then how to analyze data inside a box and whisker plot. Now box and whisker plot sounds kind of like what the name is. In a box and whisker plot you have a number line. On that number line, or underneath that number line, you have what's drawn, literally, a box. So you have your box. Inside the box, or at the end of the box, you have what are called whiskers, coming out in both directions. So we have two whiskers, one on each side. Inside your box, you also have you have a line drawn. Sometimes it's in the middle, sometimes it's off to one of the sides. Now this line, this point on the number line, is your median. The end of your box, the point at the end of your box, is what's called the lower quartile. Point on the upper number lined end of the box is called the upper quartile. The very end of your whisker, on the high side of the number line, is your maximum. The lower end, ending point of the whisker is the minimum. So this is just going to be another way to organize numbers, organize data. And it displays data alongside a number line. And quartiles divide the data into 4 equal parts. So you have from the minimum to the lower quartile is 1 part. Then you have your lower quartile to the median is your second part. The median to the upper quartile is your third part. Upper quartile to the maximum is your fourth part. So quartiles, it's important to understand, kind of like a quarter. Quartiles are going to divide the data into 4 equal parts. Just like a quarter of an hour or a quarter of a dollar. Those are 4 equal parts. So quartiles divide your data into 4 equal parts. Now on your number line, that might not look like they're all equal. Right, this second quartile here looks smaller than, like, say, the fourth quartile or the first quartile. But the amount of data in there is going to be equal. Even if on the number line it doesn't look the same. The median is the middle quartile. So I'm going to go ahead and show you an example of how to make a box and whisker plot. This will make a lot more sense as we actually go. So over here on the right I have the United States crop harvests from 1988 all the way to 2000. How many millions of acres were harvested? So step 1, when you're making a box and whisker plot, step 1 is to arrange the data in number order, so least to greatest. Least to greatest. So we're going to go ahead and do that, and then we're going to find the median also as we do that. So that's going to be one of the points that we end up putting on our box and whisker plot. Right, it's that middle quartile is the median. So we need to find that median. So we're going to list our numbers in order. So our smallest number on this list is 298. So we'll list that first. And then we'll go through the numbers. Next is 308, 314, 317, 318, 318 again, 321, 322, 323, 326, oops, 326, 326 again, 327, 333. All right, now the middle number in this set of data is 321. There's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Wait, did I do that right? 1, 2, 3, 4, 5, 6. Sorry, there's 6 on each side. Double counted here. So there's 6 numbers on both sides of 321, so 321's in the middle, so that's our median. Step 2, now that we have our median, is going to be to find the upper and lower quartiles. So we need to know what point is my upper and lower quartile. It's the point I'm going to be ending the box with. Now to find the upper and lower quartiles, you have to find like the upper and lower half. What's the medians? Those are the medians of the upper and lower halves. So essentially what you've already found is by finding our median 321 of the whole set of data, now we have 2 smaller sets of data, right? We have a lower half, and then we have an upper half from 322 all the way up to 333. So we're going to take and find the median of those 2 sets of data. Now there's 6 numbers on both sides, so to find the median, it's not the middle number, you have to average the middle number. So for my lower half, my lower quartile, the median is my 2 middle numbers are 314 and 317, so I'm going to average them. 314 plus 317 divided by 2 equals 631 over 2, which equals 315.5. So that's my lower quartile. Now my upper quartile, again, there's 6 numbers, 322, 323, 326, 326, 327, 333. So I'm going to find the average of my upper median. So my 2 middle numbers are 326 and 326. So I'm going to add those together. Whoops, 326 over 2 equals 652 over 2, which equals 326. So you have the same number divided by 2, it's just going to be itself. So I have my upper and lower quartiles now, and I have my median. So step 3 now, all we have to do is take these 3 numbers, my median, my upper and lower quartiles, and I'm going to draw them on a number line. So my first step, or step 3, sorry. Now that I have those, step 3 is to make a number line. And then we're going to mark the minimum, the maximum, median, and upper and lower quartiles. Okay, so I'm going to start by drawing my number line. Now the numbers on this number line, I'll label my number line here. This is going to be crops harvested. Right. Crops harvested in the U.S. by millions of acres. Now my smallest number on this list was 298, so I'll go by tens. So I'll go 290, 300, 310, 320, 330, 340, 350, Alright, so my minimum, my smallest number was 298, so I'm going to mark that. So that's right over here. You're not marking it on the number line, but you're marking it underneath the number line. The greatest number on my list was 233, so just above 330. I'll make a dot. Now those are the endpoints of the whiskers. Now where the box is going to start is at my lower quartile, so 315.5. So halfway between 310 and 320, I'll have my upper quartile or lower quartile. My upper quartile was 326. So halfway between 320 and 330. So now I can draw my whiskers. And then the box is going to connect my lower and upper quartiles. Now the median is, let's go back, look at that. My median was 321. So just past 320, I'm going to draw another point and a straight line through that. Oops. Through the point. Okay, and there's my box and whisker plot. It shows my minimum, my maximum, my lower and upper quartiles, and the median on this set of data. Alright, so I'm going to have you go ahead and do an example on your own, practicing with making a box and whisker plot. So your list of numbers are 5, 2.5, 6, 8, 9, 2, 1, 4, 6.2, 18, and 7. So go ahead and draw a box and whisker plot for this set of data. Follow the steps that we just went through, and then once you've done this, you can hit pause on the video and check your answer. Alright, you should have reordered your numbers 1 through 18, found that the middle number was 6, so your median is 6. You should have found that the upper and lower quartiles, the upper and lower halves, 1 through 5, the numbers there were odd, and so 2.5 was your median, the middle number there. 6.2 up to 18, again there's 5 numbers, so your middle number is 8. So your upper quartile is I have that reversed. Your lower quartile is 2.5, and your upper quartile is 8. Then you can take and put those numbers on your number line. So your minimum, the lowest number on your list was 1, so you put a point at 1. I did single hatch marks, 1 through 18. You put an upper point underneath 18. Those are going to be your endpoints of your whiskers. The endpoint of the box is going to be at 2.5, your lower quartile. The upper point of the box is going to be at 8. The median to the line through your box is going to go at 6. Then all you have to do is connect, make your box, make your whiskers, and you have your box and whisker plot. Alright, now we're going to work at comparing sets of data. So another way of comparing different sets of data is to draw box and whisker plots above one another, so you can kind of see how their medians line up, or see how their minimums and maximums line up. It's another visual way of exploring data. So we're going to do an example with comparing orca whales versus hippopotamus masses to see the weight or mass difference between them. So the masses of orca whales, oops, I'm going to list my data set here as, we'll put it in number order to begin with, so 2,200, 2,600, This is just a sampling of some orca whales, 2,600, 2,750, 3,000, 3,100, 3,700, 4,000, 3,900, 4,200. Now our masses of our hippopotamus our sampling here begins, our smallest one has a mass of 1,800, 1,900, 2,000, and this is in kilograms. I should say. Both of these are in kilograms, so we're able to compare directly. 2,300, 2,500, 2,700, 3,100, 3,600. All right, so we have our data sample. I feel like I'm missing a number in one of these. All right, I was missing 3,000 in my data set. They each have 9 samples. So 3,000 fits right in there between the 2,700 and the 3,100. All right, so we're going to draw a number line and compare these two data sets. I already put them in order, so my middle number is 3,000 for my masses of the orca whales and 2,500 for masses of the hippopotamus. To find my two middle numbers for the lower quartile of the masses of the orca whales are 2,600. So you know that it's just going to be, when you average those, it's going to be 2,600. For the masses of the upper quartile, 3,700 and 3,900 are your two medians. The average of that is 3,800. For your lower quartile, for your hippopotamus, 1,900 and 2,000, so 1,950 is the median. You have 3,000 and 3,100, so 3,050 as your upper quartile. You have your minimums and maximums. So we're going to go ahead and draw 2 box and whisker plots right over the top of one another. So to choose our range of data points, or to choose our scale, we're going to look at kind of what's our lowest and what's our greatest. We go from about 1,800 up to our maximum is 4,200. And all of these are in increments of about 100. So I'm going to just do a wide range on my diagram here. So I'm going to start at 1,000, 2,000, 3,000, and 4,000. All right. $4,500 is my greatest. All right, so I'm going to go ahead and draw these. I'm going to do the mass of the orca whale as my top box and whisker plot. So we'll put orca on top. Now my minimum for my orca is 2,200. It's going to be right about here. Then I'm going to have my maximum is 4,200. My median is 3,000. My lower quartile is 3,800. My upper, oh sorry, that was my upper. My lower quartile is 2,600. My upper quartile is 3,800. So I'm going to go ahead and draw my box. And then draw my whiskers. Oh, whoops, I did that wrong. My box is here. My whiskers from 2,000 up to the 2,600. My upper whiskers from 3,800 up to 4,200. I'm going to go ahead and draw my hippopotamus. Scale underneath. So my minimum there is 1,800. My maximum is 3,600. Okay. My median is 2,500. My lower quartile is 1,950. My upper quartile is 3,050. I'm going to draw my whiskers. Alright. So now you're able to compare and visually see that the upper quartile of the hippopotamus lines up with the median of the orca whale, right? And overall, the orca whale, its minimum is greater than the lower quartile of the hippopotamus. So orca whales have a much greater mass on the average than the hippopotamus does. So it's just a way for you to compare. I'm going to label this as, our animal masses is the comparison in kilograms for the orca and the hippopotamus. It's a way to visually see how those data sets compare. Alright, so I'm going to have you practice this on your own now, making two box and whisker plots, one on top of another, to compare annual video sales versus CD sales. So they're sold in terms of millions, or these numbers are in terms of millions. So you have two sets of data. Go ahead and draw a box and whisker plot for each underneath one number line. Alright, you should have reordered your the sales in terms of number order. You should have found that 22 was the median for videos, and 17.5 is the median for CDs. The median of the lower quartile is between 16 and 17, so 16.5. The median for the upper quartile videos is between 24 and 28, that's 26. The median for the lower quartile for CDs is between 16 and 16, that's 16 still. The median in the upper quartile for CDs is between 22 and 24, which is 23. You should have drawn your number line, compare and make sure that yours is accurate. The 15 is the lower number for CDs, your maximum is 25. For videos, your maximum is 30. Alright, we're going to do example 3 now. We're going to practice describing the data based on what we see in a box and whisker plot. So we have this box and whisker plot showing exam scores. So we can describe it by saying, well, first of all, we know the highest score is going to be our maximum. The highest score on the exam was a 90. The lowest score was a 50. Lowest score 50. The median is 75. You know that at least half the data set is within 10, right, from 65 to 75. Within 10 points of the median. You know at least half, and at least another half of the scores is within 5 points of the sorry, not half, a quarter, right? So a quarter within or 10 points, within 10 points of reaching 75, at least a quarter of the students are within 10 points of reaching the median score, and 1/4 of the students are within 5 points above the median. Together you could say that's 1/2 of the students are within 10 points of the median. Can lump that together and say a quarter and a quarter, that's a half, are within 10 points. That's pretty good. But since, you can also say, since the quartiles are not, and the medians aren't evenly spaced, the data is not evenly distributed, right? This lower half and this upper half, or even our lower quartile and our upper quartile are not evenly spaced, so the data is not evenly distributed. It means there's more numbers on one side than the other side, or more range of numbers on one side than the other side. So I'm going to have you go ahead and practice this on your own. Describe everything you can think of to describe this data set. What do you know about these numbers? Go ahead and do that. Hit play when you're done. Alright, you should have found that the highest value was 45. Your lowest value is 15. The median was 35. And at least half of your values, the lower and upper quartile combined, are within 10, right? From 25 to 35, and then from 35 up to 40. So they're within 10 in both directions. Or overall, at least half of the values are within 10 units of that median. We're going to now compare box and whisker plots to analyze two sets of data. This is slightly different than the first time we compared sets of data, because now instead of just visually comparing them by being given a number set and having to put them on a number line one under the other, now we're going to make some conclusions. Draw out some conclusions based on this data. So looking over here, this box and whisker plot compares the percents of the United States voting age population who said that they registered to the percents who said they voted. So we're comparing those who said that they registered to percents of those who said they voted. And what conclusions can we draw? Well, let's see. The range, at the percent registered, here there's not a huge range. Therefore, you know that the percent registered was pretty constant over these range of years from 1990 to 2000. Percent registered was fairly constant because that is a narrow box and whisker plot. Percent of people who voted varied more. From 1990 to 2000, we had a wider range there. But you know that that entire time from 1990 to 2000, the percent of people who voted versus those who registered was less. So you can draw the conclusion that many people who registered did not vote. Because more people registered than voted. So that's the conclusion we can draw from this. The fact that our number of people registered has higher numbers for the entire number line or data set than those who voted. People who voted overall in that entire time period was less than all those who registered in the entire time period. Therefore, we make the conclusion many who registered did not vote. All right, now I'm going to have you practice this on your own. There's this diagram here shows a box and whisker plot of Olympic basketball players' height in inches. So looking at this, comparing the men and women, what can you conclude about the heights of Olympic basketball players? Hit pause on the video. Once you've written down your conclusion, you can hit play. Alright, you should have found that when looking at this number line, the median for women was 71 inches. The median for men was 79 inches. The range for women was about 10 inches from the smallest to the greatest, and the minimum to the maximum. The range for men was 12 inches. The conclusion you can draw is that most of the men are taller than the tallest woman. Right, your lower, all the way from your lower quartile up to your maximum for men, that's 3/4 of the men are greater or taller than your maximum height for women. So 3/4 of the men are taller than the tallest woman. All right, your in-class work is to do numbers 7 through 13, odd, and then number 14 on page 620 in your textbook. And then for homework, you're to do practice book lesson 12-3. All right, go ahead and get started. And don't be afraid to ask Ms. Wall if you have any questions.